It's been a few days since the release of GPT-4, and AI Twitter is buzzing all about it. I've gotten questions from some of you about what's the difference between GPT 3.5 and GPT-4. I put together this little rundown to help explain some of it. Hey, welcome to Chaos Theory, where we find the signal and the noise in all that's happening in tech, AI, and life. I'm Alex, your resident chaos coordinator. If you like content like this, be sure to like, comment, and subscribe. And let me know what you want to see next. I'm experimenting with a few different content ideas, and I love your feedback. Now, let's dive in. Alright, GPT-4. So OpenAI shocked the world this past week when they announced the next series of their GPT model family. Andrej Karpathy called it incredible. The fact that it's multimodal, you can see that it's on trend with regards to scaling laws. We'll get into that in a bit. But it's also deployed on ChatGPT Plus, one of the premium products that OpenAI announced. So what's GPT? So GPT stands for Generative Pre-trained Transformer. This model is a large language model that's trained not on any specific task, but it's only asked to predict the next token. So what's a token? A token is just 4 characters of English text, such that 100 tokens is about 75 words. OpenAI released this tokenizer tool such that you can enter some string and get back the number of tokens and characters it uses. It's a handy little tool, especially if you're trying to build on top of these models. So the GPT models have evolved over the past few years. From the original GPT-1 paper, which was improving language understanding by generative pre-training, to GPT-2, which is language models are unsupervised multitask learners, to GPT-3, language models are few-shot learners. We've seen these models get bigger, trained on more data, include more parameters, and feature more context. But these models had a problem, what's known as the alignment problem. What this means is that these vanilla GPT models were not necessarily aligned with human values. They could be unhelpful. Sometimes they might not follow your instructions. They could be uninterpretable, difficult to understand, especially if they're making particular decisions. They could also be biased or create toxic output. These GPT models could also hallucinate by making up non-existent or fake facts. As such, OpenAI embarked on this journey to try to make these models better, to make them more aligned to human values, and to even be able to incorporate human feedback into it. So what resulted from that was this new model called InstructGPT, or the early stages of GPT 3.5. This model was unique in that it was specifically trained to follow directions and make it more aligned to human feedback. How they went about doing this is by using a technique called reinforcement learning from human feedback, or RLHF. And as you can see from this family tree, the GPT series really branched off from the GPT-3 base model. The Codex model, which if you all remember is the model that's powering GitHub Copilot, was based off of GPT-3 and trained on code. But the InstructGPT model was trained on instruction fine-tuning. These models got combined with TextDaVinci 002, put together with RLHF, became the GPT 3.5 series, known as TextDaVinci 003 and our infamous ChatGPT. So this is how OpenAI has been solving the alignment problem, and we can see how they're using these same techniques to train future iterations of the model. So right, with InstructGPT, OpenAI got people to evaluate the GPT-3 answers and fine-tune those models with those responses. With ChatGPT, they took this GPT 3.5 model and created a variant of it that was specifically fine-tuned for chat or for conversations. So GPT-4 is meant to be the next generation of these models, and OpenAI is claiming that they surpass human-level performance across many professional and academic benchmarks. One of the things that's true about this report, though, is that OpenAI is not publishing much technical details about the actual model architecture, the number of parameters, the size, what data sets they're using, the training methods. And as such, it's caused some controversy because some people are wondering, is OpenAI really so open anymore if they're not sharing these results to the broader research community? And we saw how people on Twitter and Reddit caught on to this hype train, especially in the weeks leading up to the GPT-4 announcement. The reality is that we don't know. We don't have these model details, and only OpenAI has access to them. But this is what we do know. GPT-4 is a large multimodal model that can handle text and image inputs and outputs. What does that mean? Well, they give a few examples of this. So we see in this image, GPT-4 being tasked with being able to describe what's funny about this image and to do it panel by panel. And we see that it was actually able to take that and explain the humor of it. Same thing with being able to interpret charts and graphs So we saw GPT-4 being able to take a chart like this and actually being able to answer a math question about it. Same thing here, where it's presented with a physics problem filled with formulas, diagrams, and different pieces of text, and it's able to answer the question and explain the reasoning of it. It can also just explain memes overall, like what's funny about this picture. And we can see GPT-4's reasoning capability come in, where it says the humor in this meme comes from the unexpected juxtaposition of the text and image, which is basically all memes in general. So what's the takeaway? GPT-4 is more accurate, reliable, creative, and aligned with human values. It also shows off human-level performance on various professional and academic benchmarks. OpenAI shared their evaluation results where they took many AP exams, SAT exams, the LSAT, and even some random ones like the sommelier exams, and showed that GPT-4 actually scored in the 90th percentile for all of them. That's in the top 10%. Just from these results alone, if GPT-4 would apply to university, I'm pretty sure it'd get in. So what are some of the main takeaways from the paper? Well, one, we know that OpenAI trained a massive model, we just don't know how big, on a custom-built supercomputer. OpenAI has this partnership with Microsoft where they're making use of Microsoft Azure's supercomputer to train these super powerful models. This supercomputer hooks up tens of thousands of GPUs in a high-throughput, low-latency network. The computation workload for this is massive. If GPT-3 at the beginning costs almost $5 million to create, imagine how much GPT-4 would cost. In order to achieve these results, OpenAI had to solve some real key problems in scaling up their deep learning. For one, they had to use model parallelism and data parallelism to distribute the model and data across multiple GPUs. They also had to use gradient accumulation and gradient checkpointing to reduce the memory usage and communication overhead. They also made use of mixed precision and an adaptive learning rate to speed up the convergence and ultimately improve the accuracy. And the key learnings from GPT 3.5 were baked into GPT-4. They used the techniques of reinforcement learning and human feedback to align the model using adversarial testing and ChatGPT feedback. They then evaluate this model on a wide range of tasks and domains. One of the key things that came out during the GPT-4 launch was this OpenAI evals framework. This open source framework provides several tools for automating the evaluation of AI model performance. Some of the metrics they used were accuracy, precision, recall, and the F1 score, classification and question answering tasks. They also made use of other metrics like perplexity, BLUE, rogue, meteor for generation tasks. For standardized tests, they just took the normal scoring of the SAT, LSAT, MCAT, and others. And for professional tasks, they took GPT-4 and just ran a simulated exam experience. So what are some of the open challenges? Well, one, how do you ensure scalability, stability, and reproducibility of the training process? Some of the big things that OpenAI faces is being able to reproduce its results. But one of the things that they know in their paper is because of predictable scaling laws, they're now able to reasonably have confidence in the results that they ultimately produce. And one of the key things about being on the Azure ecosystem and having Microsoft as their partner is that their training runs for creating these models is a lot more stable and scalable. But some of the other issues that they have is how do you handle data leakage, bias, and generalization in evaluation? Data leakage is a real but unexplored problem in these large language models. Basically, how do you know whether the model has actually been trained on data that it was meant to predict? If it was the case that the data actually leaked into the training set, these models might actually just be memorizing the data and regurgitating the output. And also, what about bias? A lot of the content on the internet isn't neutral. It's often biased in one way or the other. So how's OpenAI actually choosing which data to include? And also, how do we know whether or not these models are generalizable? Anecdotally, we're experiencing the power of these models, and we're seeing them generalize across many different use cases, but it's very hard to pin it scientifically. And lastly, how do you actually deal with the ethical, social, and environmental implications of the model? In one of the interviews with OpenAI's co-founder Ilya Sutskever, he actually said that it was a mistake for OpenAI to open source their research before, because of the fact that bad actors could just take that research and potentially use it for ill purposes. And in the whole area of responsible AI, where these models can output very sensical and confident responses, but also hallucinate and still generate toxic content, how do we know whether these models are truly aligned with human values? And also from the environment. And these models are power hungry. They're consuming lots and lots of GPU compute cycles and eating a ton of electricity to do so. So this is where we're at. GPT-4 is capturing the world's imagination. It's super powerful and it's able to do a lot more. Because it's multimodal, it can now read in images and output very believable pieces of text. It's certainly a remarkable feat in human engineering, and I'm personally excited to see what happens next. But a lot of open questions still remain. What do you think about it? Be sure to leave a comment below. Until next time, here's Alex, your resident chaos coordinator.